Okay, hopefully we've got you all on the edge of your seats for part 2. We've installed the the heatsink on the NVMe drive, and now we're going to test to see whether it's made any difference at all. So let's begin by running our little stats poller. There we are. And how we're looking for numbers. So the one without the heatsink is 44C. So I think there may be a temperature drop there. I can't remember what it was before. If we have a look at our... Hang on, open the folder. Where are we? We're in... Ooh, gosh, that was loud. There we go. Wrong folder. I think this is actually in project... What? Well, that's damned annoying. Alright, it won't let me get to anything because it's trying to open a folder. So that's D projects HD info poll stats. So first of all, I'm going to open the... Let's just cancel that for a second. Sorry, we did have the folder open. I'm unwell. I have COVID, so, you know, be patient, please. So we can have a look. We've got disk. I wonder if there's a... There is a CSV install. That's handy. Hopefully we can format this data out and we can view it more easily. We shall see. Yeah, okay, I can see it, sort of see what it's doing there. It hasn't reformatted it for me, but it does make it a little bit easier to see what is what. So disk 0 was 48 and disk 1 was 47. So it looks like just by putting the heatsink on, we've reduced it by 2 or 3 degrees centigrade. Yeah, 47 along there for disk 1 temp. It is a warm day. You can see it obviously peaking around here. This is obviously the data from before. It's looking very flat, so I think we've ran it for long enough. Now we can run the whatever I called the stupid app. I don't think I need to use the virtual environment, but let's just use it anyway. So let's run the Writernator. We can see it's coming up. We're on a different time scale, so I just paused it for a little while there. I had my family come home and have a chat, so I didn't want to capture all of that. But based on what I'm seeing so far, we haven't reached steady state yet, but it's very gradual. We're only at 64 degrees. So I think, you know, if this is a first order system, which it looks to be, we probably have a much larger tau value. It does look like it is starting to step down a little tiny bit, but generally the throughput is still around, you know, 6 gigabytes per second, which is still significant. So maybe that's bits. I should check that. Yeah, it looks like we haven't reached any thermal throttling or anything like that. So I guess I'll pause it and run it for a bit longer. Alright, well, it's been running for over 10 minutes now, and it's up to 70 degrees centigrade. Maybe we'll get another 1 or 2 degrees climb out of this, but it's looking very close to its final final steady state value, it certainly looks like this has been trending down, but it could just be almost an optical illusion. It does look like it has come down. Comparing it to the temperature of disk 1, disk 0, which has remained very constant throughout this entire process. So I'm gonna stop it there, and but to me, I don't even need to look at the CSV files. It's a clear winner. A huge upgrade for $10 or however much I paid for tiny little NVMe heatsink. Massive improvement. No thermal throttling. Pretty much a consistent high write speed. Yeah, just a simple $10 heatsink and half an hour of your time can hugely, in my opinion, improve the performance of your SSD. So, if you have an NVMe drive that doesn't have a heatsink, just go order one, and maybe I can make this code available so you can test it yourself, or you can write your own code or test it however the hell you like. That's entirely up to you. But I think you're missing out if you don't have a heatsink on your NVMe drive. There's performance there. It's very easily and cheaply obtained, and I highly recommend that you go ahead and do that. So I'm going to stop the writeinator, and we're going to watch the curve come down. So I'm expecting it to fall far quicker than it rose, and that's because it should lose heat more quickly, and it certainly seems to be the case. I don't think it would have the same. It should have the same tower. It should be symmetrical about going up or down. Yeah, that's interesting. I don't know how that works exactly. So, but yeah, definitely we crossed 83. We peaked at 83 degrees centigrade on our earlier testing with no heatsink, and on this occasion we peaked at about 71. So we might have reached 72 given enough time, but I think enough time has elapsed, so I'm calling it there. Yeah, I guess what comes next is we will compare the data, and we will see just how significant, see what some of the major differences are between these two scenarios. But I don't even think it's necessary at this point in time. We've ran it. We've seen what the change in temperature is. It started off at a slightly lower temperature as well, which makes perfect sense. And we could even see that there's a direct impact on throughput as well, as it does appear to be that there is some sort of thermal throttling taking place. You'd hope so. If 83 is the maximum temperature, then at some point you're going to have to find a way, to protect the silicone, protect those chips from melting, either the balls of solder starting to melt, or crack, or even thermal stresses within the chip itself. So, silicon isn't magic. There is an operating temperature, and 83 is certainly getting on the toastier side of things there. So it makes sense that there was thermal throttling taking place. So yeah, definitely the difference between a drive that will do, I must check, is it megabytes per second, megabits per second, 7 gigabytes per second? That seems like an awful lot. Maybe that's right. I'll have to check. Maybe my units are wrong. Either way, it's a bigger number than before. So that's great. There certainly wasn't the thermal throttling. Let's park that there. Cool. So we've exported the results from the two tests into CSV files, or opened them up in LibreOffice, and we've graphed. I've set up the axes the same to give the same relative. They're switched, left to right, but that's fine. So the ranges are the same, 90 and 8000, and the time scale, relative time scale, is the same as well. So the full duration of this one at the top, which is the first one without the heatsink, was 12 minutes. So you can see hugely higher rise there. This is a much gentler rise, so much larger tau value there if we're going by first order system. And you can see that this one here peaked at around 83 over here, where this one peaked at around 70. So a difference of around 13 degrees, 12, 13 degrees, huge. And of course you can see here it's thermal throttling, and then after that it's sort of all over the place there. So as you can see, much longer duration, 25 minutes versus 12 for a steady state, and then take the load off and reach a new steady state. So there you go, there's the results.